Hello and welcome to another one of D's ADD videos. Today we're going to look at a couple fundamental examples or basic examples of product rule. So the first one's here, and technically if you wanted to, you could do algebra. You could always multiply this out. There's no 3 or 4 exponents here grouping these together. So you could take the 3x times all of that, the 2 times all of that, combine your like terms, and then do the power rule like 6 or 7 times. Now that seems like a lot of work when you could just do the chart. So let's do the chart. We're going to let u equal 1, v equal the other, doesn't matter which one. Take the derivative. So this is the power rule, the 2 comes down, and then you subtract 1, so it's 2x to the understood 1 right there. The derivative of a number x is always that number. And then derivative of any constant, there is no rate of change in constant, so it's 0. Then, oops, let me use u prime instead of du, sorry. It's midnight, long days, long weeks. As I write v there, that's a u prime. So then v prime is going to be just 3. So if you plug into the formula, remember it makes that x shape. This times this, plus this times this. Pretty straightforward. So you're going to have 3 times x squared plus 4x plus 1 plus 2x plus 4 times 3x plus 2. Now step 3 is to simplify if you can. Most professors will just test you on your calculus skills, not your algebra skills, but this is not too bad. You should be able to distribute the 3 through. FOIL that out. Combine your like terms, 9x squared. You got a 12 and 12x, and then a 4x, so that's going to be 24, 28x. And then 3 and 8 gives you plus 11. So that's your f prime, or your dy dx, however you want to look at it, same terminology. All right? All right, next problem is right here. So I didn't want to make this about chain rule or anything else, but you know, to do 2 examples like that would be boring. So to change it up a little bit, let's bring the 2 down. When we take the derivative of the 4x plus 1 squared, so the u prime becomes 2 comes down. Rewrite the expression. This is chain rule. Treat it as if it was an x. Subtract 1 from the exponent, then take the derivative of the inside, multiply it. So times derivative of 4x is 4, derivative of 1 is 0. Then v is 3 minus 2x, v prime is negative 2. Do your little crisscross, and you're going to get negative 2 4x plus 1 squared plus 2 times 3 minus 2x times 4x plus 1. So that essentially would be correct. What we got going on here though is a little algebra that we could do. You could FOIL this out, and then distribute the 2's. That seems a little bit more difficult. Let's be elegant about it. Let's move out the 4x plus 1. That's common. You see how there's 2 of them here and there's 1 of them there. So that means there's at least 1 of them in both, so we can pull it out in front. I'm also going to pull out a negative 2 to make that first term positive. And then you'll be left with 4x plus 1 in the first set. If I take this divided by this, had over factor, plus, actually no, minus, sorry, the 2 divides out, the 4x plus 1 divides out, so it's going to be minus 3 minus 2x. I'm going to go ahead and distribute that minus sign to give me that. Okay, had over factor, basic algebra. 6x minus 2 all I did was combine the 4x and the 2x and the 1 and the negative 3. And that would be a very simplified answer. Okay? Try to practice this simplification I'm showing you, because you're going to be doing extrema here pretty soon, and you'll be asked to set the first derivative equal to 0. If you FOIL all that out, combine your like terms, it's going to take you forever. This is a pretty quick process that'll get you to equal 0 pretty safely and allow you to set each one of these individually equal to 0 and find your what I call critical points. That's a different story altogether. I hope I've set you straight on the basics of product rule. Check out the more advanced examples, because they do get a little trickier, and more importantly, practice, practice, practice. Thank you, and have a nice day.